talk, somewhat technical, sort of half technical, half soft technical, I guess, about how to make scalable software, but more than just the algorithms and the computer science. How do you make a team, and how do you manage a team and run a team that can maintain scalable software and keep it working? Then we'll go over some opportunities at Google, and there'll be time for questions at the end, I hope. I'll be here afterwards, so if anyone wants to catch up with me. So Google. So there's their slogan. Our mission is to organize the world's information and make it universally accessible and useful. It was founded in 1999, so it's been around a little while now. Google's made a lot of different products over the time. You know, everyone knows about search. I mean, that's the big one. But Google's actually doing a lot more than search these days. There's some little icons of different products that they have. You've got like Drive, Chrome, the navigation part of Maps, G+, Google Earth, Pictures, Gmail, and it just goes on. And there's even more than that, like that's just a sample. So it's a big company. But, you know, because it has so many different products and so many different teams, I always find that each team kind of feels small in a sense, but within a big organization. So working at Google, you know, I've been there just almost 2 years now. I haven't jumped ship, so that's good. I mean, that must be a good sign, right? So yeah, if you hear about free food and like weird perks, like crazy decor, and that's there, if that, you know, that's what something you want, it's definitely there. But there's more to it than just what you see in pictures. You know, there's a real focus on bringing out the best of every single employee and providing an environment and support structures so that every person there can really maximize their potential. And that's true whether you're there as full-time or you're there as an intern. So some of the things that they do, openness. It's definitely true that Google's very open. You know, there's the TGIF thing, God's Friday, which is actually on Thursday, so that offices around the world can participate. But you know, you can go up to the mic, standing in front of like Larry Page, and ask him a direct question, right then and there, put him on the spot. And you can do it all the time. And then there's other ways to ask questions. They have their own Q&A system. You can send questions wherever you are in the world directly to the executives, including not just Larry Page, but everybody in charge of all the different products and groups. There's like, you know, there's their board of directors. They'll have meetings. They'll have presentations about what was discussed. They have sessions with lawyers to discuss legal issues people might be interested in, or policy things. Then, of course, there's technical openness. You know, as an employee, I can see all of the source code, like with very, very minute exceptions. It's all there. And I cannot just look at it. I can write a change and send it to someone from that team, whoever it is, and make a change and participate in all kinds of things. Again, design documents, things like that, describing the rationale behind why a system is the way it is. By default, it's open. You know, unless there's a very, very good reason, by default, it's open. And the vast majority of such documents are open and available for everyone to read and understand. There's scale. You know, Google's a big company. They have a lot of revenue. They have a lot of users. So, you know, there's a big opportunity it's quite interesting that Google focuses a lot on doing big improvements. They like big innovations. They like to disrupt, and if they can, and bring new ideas to the market. The so-called 10 times change, 10 times better than it was before, 10 times bigger, whatever it is. They want big impact. But also remember that when you have a billion users, even a 1% improvement adds up. Over a billion people, it adds up to a lot. And so there's all kinds of opportunities there with scale. And like voice, like I was saying earlier, the TGIF, you can just go up and talk to an executive and ask them questions, well, such as executives, anybody. And people are very open to that. People are very let's just, lights.
I was just wanting to bring them down just a
Yeah, let me do that. Okay. Oh, there we go. There we go. Okay, so, where was I? Voice. Yeah. So there's that. There's Google Guides. It's an annual survey of all the employees, and it's there are half of it are rate this, rate that, and then half of it's just free form, say anything. And those messages are passed on to managers and executives, and they look at it. They do a detailed analysis. I just filled out the survey, and I was very frank. I didn't hold anything back, and you don't need to. That's the expectation, is that if there's a problem, if you have a question, if there's something you understand, if there's something you think can be done better, go to whoever's in charge of that. And if nobody's in charge of that, then make a proposal to start doing that. Right? It's very open. And support, there's all kinds of perks, there's all kinds of benefits. Again, it's about trying to make sure that the potential of everyone is maximized. Focus on the well-being of employees, and all else will follow. Just as when you deal with the products, there's a philosophy, focus on the user, and all else will follow. Trying to take a holistic view. There's stuff about your health care, there's financial, counseling and sessions and talks available for dealing with finances, opportunities to socialize. And when you're coming out of university, and I know it was true for me, you come out of university, you have this job, you have all this income coming in, and you don't really know the ins and outs of dealing with all of this financial stuff. Maybe you want to buy a house in some way, and you've never done that before. They realize that a lot of people are going to be coming into new situations, and there's actually resources available to get information on that. Just like at the office, you don't even just go over to that building on Thursday, and there'll be someone you can ask, which is kind of interesting. And they continually invest in these kinds of efforts, and they try to also back it up with data. They do go to great lengths to analyze what they're doing, what the outcomes are. Is this actually working? So it's not just guesswork. It's empirically based. Whenever possible. And they go to great lengths to do that. Okay, so that's my introduction to Google. Again, there should be time for questions at the end, and I'll be hanging around. I'm going to start going to my little bit more technical talk. I am a software engineer, so this is what I know best. So let's begin. So you want a scalable product. Well, you need scalable hardware, for one. You need a computer the size of a warehouse. Multiple. And, so these are designed for massive services. These are, they have a common system software. They also speak the same language. And they also all share resources, so you can tell this warehouse I need so many CPUs effectiveness here, the very building itself and its infrastructure, its cooling systems, its electrical systems are integrated with the computation machines, with computers. It's a holistic system. And these large things could use dozens of binaries and thousands of cores, hundreds of thousands of cores for one service, one application. And of course, all this is available to you from Google Cloud if you are interested. And there are other services like Amazon, as they're well known, AWS, and plenty of other providers out there too. So, but that's something you're going to want to have, because you don't know if tomorrow you're going to go from 0 to tens of thousands of simultaneous users. You get like really good press all of a sudden. You need to be able to scale. So this is just a picture here. This is actually 2 data centers. You can see they are quite large. So you can run your things on that. And there's lots of companies doing this nowadays. So what else do you need? You need your systems, your basic software infrastructure, mechanical file system. And that needs to scale too. You have to be highly fault tolerant. You have so many machines, everything will break at some point, and probably all at once at some point. Your disk will break, your service will break, your network will go down, your fiber optics will get cut. You're going to find bugs in your software. There is that like heartbeat thing, and what are you going to do when when a bug like that comes out, and you need to roll out a fix across this whole thing? When you're building these, you're considering like these kinds of software infrastructure, these are things you need to think about. How am I going to deal with a bug that's serious? The files in particular, they check on everything, they replicate everything, generally at least 3 times. Sometimes a lot more. Like I've seen services with like 20 times plus replication for geographic locality, so the data is close to you geographically around the world wherever you are. And you're talking like petabytes of capacity at minimum. Like if you only have petabytes left, someone's going to get woken up at 3 a.m. to fix that. Things start to get really big, really fast. Here's a sort of diagram. You can see like clients will talk to your masters, which have their own replicas, which track all the metadata, which tells you where your actual data is. Your data is put on these chunks. These chunks are distributed across a variety of servers with replication. They're all mixed together, and they include things like checksum and like error correction codes and things like that. So if you lose one, you can generally reconstruct it. Think like RAID 5, if you've ever used RAID 5 with these error correction mechanisms. And of course, you need your algorithms to scale. Your actual work that you want to do, that needs to scale. So MapReduce is the sort of canonical, sort of most basic example, I guess, of a scalable algorithm. Basically, you have a map function which takes a bunch of key value pairs, and this function you write it, and it takes some set of input, processes one input at a time, a key and a value, and outputs multiple keys and values. The keys could be different. The values could be modified, transformed somehow. It's arbitrary. Just some list of keys and values in any order. There will be a shuffling phase in between here, where data items of the same key are grouped together, and they're passed to the reducer. The reducer says, for this key, I had all of these values output. Do some aggregation on that, do some calculations, and come up with a set of final values. And here you can see a diagram. This is kind of what it looks like. You're saying this is maps, and you want to figure out what streets are on the tile, the square that you're looking at on your computer. You've got a bunch of streets. They're associated with different regions. There's your map. You extract out that region information. In this case, the example is like north tile, south tile, but generally you use latitude, longitude, or some other kind of tiling of world to break everything up. You're going to shuffle it, group all the N's and all the S's together. And in this case, the reduction is going to be draw everything in that type. For N, the north file, draw everything that showed up there. And for south, draw everything that showed up there. And that's your output. Your output is the rendered result. It's, cached somewhere, and when the user requests it, and they're looking at maps, that's what they get. And this is actually what happens. Like, there's actually massive computations that are run continuously that are like calculating all of these tiles and all of the data sets for them. So that way, when you go on those maps, it loads, well, as fast as your connection will allow, basically. So that's great. You have all of this hardware and these systems, this infrastructure. You have all these algorithms. You built out your application. You know it can scale. You can handle your hopefully hundreds of thousands of users, millions, billions. If everything works out. And at least you know how to get there, right? You know what you're going to need. But can you manage it? Right? Execution matters, and ultimately, these systems are built to be maintained by people, by teams of people, and you need to be able to, have your team working cohesively, working well, to keep this sort of rocket ship going straight. One of the basic things is, and it's amazing, like, how easy this is to get wrong, but having clear lines of communication. So knowing who owns what piece of the software. Who owns the production code that says, use these servers? Who owns the algorithm code that says what calculations to do? Who owns the front end? And that matters because when something's wrong, you need to know who to talk to. And because this is a big system, you might not know anything about the front end at all. Like, I'm not a front end dev. I can do a little JavaScript here or there. I can get by. But for a complex front end, like say the AdWords front end, I'm not your guy. But somebody is, and if there's a problem, and I'm on call and I'm trying to handle it, I need to know who to talk to. Ownership. And that isn't to say that ownership means, that you're the be-all and end-all of this thing. It's more like you own all communication about this. You are the contact person for this. That's what it means more than like you're a dictator of this component. No, and that's not like you're still part of a team, but you are the contact person. You are the gatekeeper. And this is what I mean. Escalation pathways. I was just on call this past week, and one of our systems had an issue. There was misconfiguration. Somebody made a change, and there was a complementary one that had to be done, and it wasn't done. And midnight comes, and I get on call. Well, actually, not me. Our production support, SRE, our site reliability engineer, or software reliability engineer. They got the call, and they knew to talk to me because I was the on-call for the software side, and this is a software problem. So they knew to go to me. I wake up at midnight. I look at the problem. I'm like, yes, I've worked with this before. I know what's going on. They say, let's do this. Let's do like an emergency patch and re-release and get it all done. At 3 a.m. it was working again. Thank goodness. It can be exciting. And so knowing that like, they need to know to go to me, and then I in turn need to know who to talk to if I don't happen to know the system, which happens a lot. So this is, this is all about clear lines of communication. Really knowing how the process for dealing with issues as they arise, and it's not just emergencies in production when something's breaking. It's like, I want to integrate with this system. I want to use this code. I want to talk to the person who understands it so I can do that correctly. So it goes beyond just production issues. It's like the whole development process benefits from this. Testing. Now testing is interesting. Like you think testing, well that's just software. But a lot of it isn't actually. Like, sure, you have to have the test written. You've got to have unit tests, at minimum. And then if you can, have tests running continuously. We have something called Lutar, which is like for very, very large tests that need a lot of machines to run on, and that runs less frequently. We do a lot of diffs. So if I make a change to a job, that job exports a lot of statistics, counters, and then the actual output data itself, and we can diff them and see if there's a change. And if the changes are unexpected, that will block your code change. And we have a whole bunch of people on our team. We call it EngProd. The formal title is Software. Oh, wait a minute. Sorry. Developer test when you're in Canada, but in America, I mean, they can call it whatever they want. And there are people who build all of these things, and they think of things about, how do we make sure we have complete coverage? How do we make sure that, we're catching 99.9% of the errors? Because we don't want somebody having to make a that's not great, and I filed a bug on that, and those people are going to be looking at that and figuring out how to make sure this doesn't happen. We have a release process. You write all this code. Everyone's been contributing for a week or so, a couple weeks. All of the changes go into into a release that's done on some schedule. It might be weekly, it might be bi-weekly, it might be every 2 weeks, or twice a week or every 2 weeks. And so this whole release process, somebody goes through there and checks everything, like are all the tests passing? What do the diffs look like? Is there anything weird? Is there anything unexpected? And then if there are changes, who owns that thing that changed, and can I go talk to them and figure out why this happened? Get an explanation. And if it makes sense, then we can go ahead. If not, maybe we need to delay this release. Maybe we need to go back to a previous version where everything looks good. And of course, you can't even run the test. You can't build anything. So, we actually have someone who's a build cop. That's what they do. They go around, nag people if something they've changed is broken in a build. And when you deal with a big system, and there's a lot of moving parts, it's easy to do that without realizing it. Maybe you didn't run every single test that you should have. You have so many tests, you can't run thousands of them every single time. You run 200 maybe, but it's possible that when something gets missed. And so, when we have these big hard tests, these continuous ones that are running all the thousands of tests that are available, and it catches something, the build cop has to be there. Someone has to be there and say like, hey, this is broken. What's going on? You need to fix it as soon as possible. Because we can't run the tests, and that means other people are being blocked. They can't run the tests they need to run. So there's like a whole human element to the testing side. And then the other side is sustainable code. This stuff has to be designed. And one of the things at Google is that people move around between projects. Like every year and a half, 2 years, 2.5 years, something like that, people will often move to a different project. Some people stay for a long time, but a lot of people move. So you have to assume that anything you write is going to be passed off to somebody else. And that person needs to be able to understand, why you did what you did, who the other stakeholders are, who are the other people to keep in mind when you're working with this thing that are relying on it. And the design document is one way, a common way of capturing all of that detail. And it's also good because, if it's a bigger change and you have time to spend on doing design, and this is high level, we're not talking write the code and put it into a document, we're talking this is the kind something that now you can pass around to other people who are like domain experts, who really are, have just a very specialized, but very great expertise. They can look it over, they can give you feedback, they can tell you things that you didn't think about, and it gets you into a better end result. And it's something that, again, is you try to keep it up to date as best you can as your system changes over time and evolves, so that it can be handed down to whoever's next. And you may not even be at the company anymore. Like, people move around in careers, so really, it's definitely important. And the same thing with code comments. I often find that code comments are the most valuable, just because it's right there, it's in context, it's right where I'm reading this code, and I'm like, I don't know what this is doing. Like, why are you doing this? It doesn't make any sense. And then having a long comment. I mean, sometimes they can be paragraphs, but really getting into it and helping me understand as a newbie, because I've never seen this code before. I'm a total novice in this, but I've never seen it. That really makes a big difference. And to make sure that that's actually happening, we do reviews. It's required from all code that's submitted. Somebody needs to review it. Sometimes I'll send it to multiple reviewers if I'm touching a lot of different systems. If it's something that's very sensitive that could have a serious impact on customers and users, I can send it to like 5, 6 people for review. And each of these reviewers follows a set of guidelines. There are high-level guidelines about like commenting and design. They'll say like, where's the design document? Link it into the change description. Why are you doing this? There's high-level guidelines which are just for everyone. Then you have more specific ones called readability, which are specific to a given language. If you have C++ readability, you have Java readability, it means that someone who is a domain expert in that language, in the style that Google uses, which is fairly homogeneous across the company. They've looked at the way that you write code. They've worked with you to make sure that it's going to sort of have that universality. It's going to follow that style in terms of like sometimes specifics, but often just the broad strokes. So that way, if somebody in Switzerland or Japan or elsewhere in North America is reading it, there is a sort of common ground there. There's a common style that they can kind of understand very quickly just by glancing through it, what things are, where, and what they need to actually drill down into. And also avoiding like gotchas. I don't know how many of you have used C++ a lot, but I have, and it's got a lot of gotchas. It's got a lot of things that you can do that work, they're correct from a technical point of view, but are hard to maintain, are easy to get wrong, and no matter how smart you are, and I've worked with some very smart people, you will make those mistakes once in a while. I make those mistakes more than once in a while. I hope that I'm smart. But, so we have people who do that, who they work with you to make sure that you're really following those guidelines and that your code has a kind of universal character. And then write your tests. You gotta write your tests. Like, I don't know how many times I've seen people get burned by that. They're trying to launch something, even if it's a simple little mobile game they're going to put on the App Store. If they had written tests at the beginning, they might have saved a day's worth of debugging, or multiple days, when they had an issue. Even the simplest things, I'm telling you, when I came in, I was kind of suspicious. I'm like, tests, I've never written a test in my life. I've never tested any code. I don't know what I'm doing. I've been saved so many times. Like, I totally admit that was a fool before learning that. I totally admit it. Seriously, there's a lot of testing frameworks out there, and the one Google uses, which is called Google Mock and Google Test, they're actually open source, so you can just go and use them, but there's plenty of open source. And culture, we have fix-it meetings. Once a quarter, we have a week where we just fix bugs, don't do anything else. Everything else, suspended. All your new products, forget about it. We're just going to fix bugs, we're going to make the code better. And sometimes we'll do 2 of those in a quarter if there really is a keeping things moving along, keeping the system healthy, and they can give you a little bit more money, maybe a lot more actually, to recognize that. And Superstar of the Month is something that my team, which is called, it's IBA, Interest-Based Advertising. It's just something that we do. Like, teams can have whatever kind of thing they want, but I think it's important you have some kind of recognition. This one here, you get this like gargantuan trophy like this. It's totally ridiculous looking. And it goes once a month to someone who's done a lot of effort on keeping the code healthy. You know, and going out of their way to make sure that everybody else is keeping their code healthy, to maintain that culture. And promotions, you know, it's strongly considered. You do a promotion, you write a packet, you say like, I've achieved these things over the past year or whatever it is, took you some period of time. And one of the things you really like that really count is that I've been maintaining code health. You know, I got a peer bonus. I got Superstar of the Month that, you know, like in October because I was doing these things. And they will very much consider that. It's definitely valued. So these are things that you can do to make sure you keep that culture of quality. And it saves you time. Like it's an investment a little bit, but it has a good return, a very good return. So now more about the opportunities. Join us, of course. So here we have some of the main technical roles. Software engineer, that's what I do. Site reliability engineer. Some people call them software reliability engineer. I don't know, it's up in the air. We just call them SREs, really. And then software engineers in test, that's like the engine product I was telling you about earlier. They specialize in testing infrastructure. And, you know, the one thing to remember is that software engineers in test are not second-class citizens. Like, they're critical to keeping this system alive. And I rely on them, you know, daily to give me advice and feedback about the systems I'm working on, the way I want to implement things. And I give them advice about where I've seen maybe some coverage is missing, where I'm worried about a system that could fail unexpectedly, and they'll look at that. You know, software engineers, I mean, they write software. Again, regional differences, you might title librarian. But I work in the States, so I'm a software engineer internally. And they're the people who are designing the new products, working on them. They do a lot of they do maintain them. And one of the interesting things with maintenance is that the SREs, like when a product is being very mature, you've ironed out all the bugs that, you know, 99% of the bugs. The SREs will start taking that over. They're like the masters of production. When your software is in a known good state, they will take that over and they will run it for you, and then the software engineers move on to the next project, the next application, with occasionally paying back if additional input is needed. But the SREs are all like well-versed, they're good programmers, they can fix almost anything themselves, they build almost all of their own administration infrastructure. So it's not like you're just like a sysadmin and you here's the tools and use it. No, like you build the tools. You build your own frameworks. You build your own management systems to manage these big data centers. Like it's very deeply technical. There are a variety of internships for software engineers. The process is kind of like you apply as a general sort of internship, and then through the process they figure out what project is going to work for you and for the various people who have projects on offer. It's a sort of a matching process. The internships, unfortunately for the summer, a lot of them have closed up, but they are hiring for the fall. Just something to bear in mind. But for those who are graduating this year, the door is always open. We have project management positions, which are, you know, managing the features, managing the interaction with your users, like trying to understand how users are using how to serve them the best way. Um, that's the focus there. There's also some information technology positions. This is interesting. You do like you can do a rotation. If you're hired full time, there's like a residency program where you can go to a bunch of different locations, potentially around the world. And I tell you, like, it's not the people I work with, like, just the fellow who set up that laptop. It's complicated. It's surprising. We're always pushing the very edge of security systems, which means a lot of it is built ourselves. A lot of it is like novel configuration. And the people in this program really need to keep on their toes because everything's always changing. There's always something new. There's always some leading edge new things that can totally mess up, and then your laptop's not working anymore and you don't know what to do. And they do all kinds of other stuff like that. So you can just check out Google.com, the jobs, the students. There's basically a listing of the different positions available. You can upload your resume and begin the process, which will look something like that. The resumes will be screened. You then, if they select yours, they'll be contacted. There'll be a couple phone interviews, technical questions, but being on the phone is somewhat limited in how much depth you can go to. So they tend to be more like, can this person actually write code kind of questions. And then if that goes well, you go on site, all expenses paid, they fly you down generally to Mountain View in California, where I work, and you do on-site interviews, you're up on a whiteboard, you write down your solutions to your problems. And then all of the feedback from the interviews goes to the committee, they make the hiring choice, and eventually an offer. And I have to say, the whole process is just getting faster and faster and faster. I think from when I started, it's gone down weeks. And they are constantly optimizing for speed, despite rumors that you may have heard. It's getting pretty fast now. I think in my case, it was like 2 months, and that was like a long time for them nowadays. And that's for full time. For interns, it's different. Interns, it tends to be like 3 phone interviews, and then they make a decision, and then they go through to match up with the project, and then there's some more calls they'll do to find a good project. And again, that tends to be faster because of course you don't have to do the on-site and fly down. The kinds of problems, if anyone's interested, just think like Topcoder. Look at Topcoder, look at the problems that people are doing in like an hour. It takes about an hour. Go to like the Euler project, like the first few dozen kind of questions, like being able to just being versed in like your data structures, in your graphs, binary search, trees, that you can just sort of fluidly work with it. You'll be okay. But do prepare. I have seen very smart people who got to that stage, didn't prepare, and it didn't work out. And it was really unfortunate. They got to go to a PhD program instead, so that's fine. Things still worked out, but like, prepare. When it comes to these interviews, prepare. At least a week. I prepared for a month, and I wish I had done a little bit more, but it still worked out for me. And then questions. And then if you haven't gotten a laptop and you haven't signed in, just check that out here. That's going to help. If you sign up, I think there's like some options to receive an email, and our recruiters can follow up with you if you're interested. And then it's also just to keep track of like how many people are showing up these things. So hopefully next time just me. So that's my presentation. Any questions? projects. I'm not saying you have to have it, but if you have them, highlight it for sure. It will be looked at. But anything else, any other projects you've worked on, definitely they'll be considered. In the back there?
Does Google have opportunities for game developers?
Actually, yes. There is Niantic Labs. I've met some of the people who work there. They're great people, and they have their mobile game. But I would say a lot of the opportunities are more like play games and the kinds of services that are provided through there. But I mean, Niantic Labs exists, so.
Do you guys have any opportunities available for networking students in the IT field?
So SRE, they are the gurus of that. They do amazing things with networking that I cannot believe. There's a lot of work that goes into the hardware. Networking is a big constraint in these big systems, and you want line speed. You want tens of gigabits per second of line speed in your networks. You want ridiculously low latency. If you can, it's going to help somebody. There are a lot of challenges and a lot of opportunities for networking and network engineering and things like that. It's a huge network, and Google has a lot of its own private fiber, but they also use a lot of public fiber provided by companies like Level 3. They have all kinds of undersea cables. I can't tell you how many times I've seen an email that says, "Oh, this cable was cut. You lost all bandwidth between these two data centers. It'll be back up eventually." And so there's people who have to consider that and design the routing sort of framework and the routing structure so it still work and consider all of these variables.
You know if there's anyone available like the one you have or self-development, like an intern?
Yeah, there's internships for every kind of job. I mean, it's like I said, it tends to be more of a big funnel, like it's sort of general, and then you sort of you figure out what project is going to be the best fit.
Are there positions available for like robotics?
Well, I'm sure you know that Google acquired a bunch of robotics companies. So I'm not going to say no, but I'm not going to say that there's a huge number. They are there. I've seen the listings. I know they're there. I just don't know. It's still worth applying. I'm just saying that it's not going to be. There's not as many as there are for software engineers. But they are still there, and there's quite a few of them, and they're incredibly interesting. I have seen some of these robots. I've seen the self-driving car. It's totally mind blowing. Any more questions? Yeah, so you're asking the time frame for internships. Most of the ones I've seen have been like 3 months-ish, kind of. That sort of time scale. It still gives you time. It's typically like I believe here it's the semester structure. There's like 3 to 4 month periods. So it still gives you time to sort of move down there or wherever it is the internship is. And when you get an internship, it's not like you have to go to like the local office. Like if your project is in California, that's where you're going. So you get you some time at the beginning and end to like move.
If you get an offer, does Google help with relocation?
Yes, definitely. Yeah, when I got my offer, there was an option to take a lump sum, or they actually had a company that totally just did everything for you. mean, I just graduated, so I didn't have much to do, so I just took the money. I mean, what else can I do?
Are most of the software jobs in Mountain View or in
They're all, Mountain View's a big office, but